Section 5.3 looks at the trigonometric functions of any angle. Up until now, we've been looking at ones that exist in a right angle, so we're going to look at any angle now. And it says, let theta be a standard angle, let theta be an angle in standard position with the point xy on the terminal side of theta and the radius equal to the square root of x squared plus y squared. That's derived from the Pythagorean theorem. So if that's the case, then we're going to find sine of theta, cosine of theta, tangent, cosecant, secant, and cotangent. To start, we're going to draw ourselves a picture so that we have a little better idea of what's going on. So it tells us that standard position, which means the initial side lines up with the x-axis. On the terminal side lies the point, let me draw a different angle here because that will give us a better. Let's say that this is the point x, y. Okay, that's the terminal side of our angle, then this right here would be theta. Well, if that's the case, then this length is y, this length is x, and this must be r. This is my theta in here, then sine is equal to, remember sine is opposite over hypotenuse, so sine is y over r. Cosine is adjacent over hypotenuse, so x over r. Tangent is opposite over adjacent, so y over x. And then cosecant is the reciprocal of sine, so radius over the y value. Secant is the reciprocal of cosine, so r over the x value, and cotangent is the reciprocal of tangent, so x over the y value. When x or y is in the denominator, the value cannot be 0. That's because we don't want it to be undefined, right? If it was 0 in the denominator, we'd be looking at an undefined value. So, given this example, let -3, 4 be a point on the terminal side of theta. Find sine, cosine, and tangent of theta. All right, I'm going to start by drawing myself a picture. I always assume that it's in standard position unless I'm told otherwise. So, let me do this. The point -3, 4, 1, 2, 3, 4. That point lies on the terminal side of theta, so this is the point -3, 4. Okay. I'm going to drop a triangle right here because I know things about right triangle trig. I know that if this is theta, I can come up with these ratios. That'll be my opposite. This is my adjacent, and this will be my hypotenuse. So this is my adjacent side. Since the x, this is -3. This is 4. If that's the case, then h, if I need to, I can use Pythagorean theorem. A squared plus b squared equals c squared. Well, 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 25 equals c squared. Plus or minus, but we just use the positive. We're talking about a length here, so c is 5. Also a 3, 4, 5, a common Pythagorean triple. So sine of theta, I'm going to look back to my values up here if I need to. It's y over r. Cosine of theta is the x value over r. And tangent of theta is my y value divided by my x value. So sine is 4 over 5. Cosine is -3 over 5. And tangent is 4 over -3. Remember that tangent is the only value that should be greater than 1 because we're talking about a ratio of sides and we're talking about opposite over hypotenuse. Our hypotenuse should always be our largest side, so the denominator will always be larger than the numerator. Therefore, the value will always be less than 1. Tangent is the only time when we're going to see a value greater than 1. All right, we're talking about the signs for the trigonometric functions that can be determined based on the values of x and y and the definitions of the functions. You can refer back to your unit circle for this. You might even want to add this to your unit circle. So when we're talking in the first quadrant, so in Q1, all of our sine values are positive. So sine is positive, cosine is positive, and tangent is positive. In quadrant 2, only sine is positive. So sine is positive, but cosine is negative, and tangent is negative. If you look back up to this example we just did, in the second quadrant, our cosine value was negative and our tangent value was negative. Why? Well, because we were dealing with the x, a negative x value, and cosine and tangent both rely on that x. In the third quadrant, tangent is the only one that is positive. So tangent is positive, sine is negative, and cosine is negative. If tangent is sine divided by cosine, and negative divided by negative, leaves me with a positive. And then in quadrant 4, the only one that's positive is cosine. So sine is negative, cosine is positive, and tangent is negative. There are certain ways to remember these. You can come up with little acronyms and ways to help you remember. Some people remember it as A, S, T, C, starting in one quadrant and going to the fourth, as all students take calculus. That's just one mnemonic device, but there's other ones you can come up with. It really wouldn't be a bad thing to add this to your unit circle. It might be pretty helpful. So given that sine of theta equals -2/3 and tangent of theta is greater than 0, asks us to find sine and cosine of theta. I'm sorry, cosine of theta and cotangent of theta. All right, I know that sine of theta is equal to y over r, so -2/3 is y over r. I'm going to draw myself a picture here. My y value would be -2, and my radius, I'm not sure exactly where this point is going to be, but I know that this value right here is a 3, so this angle, remember I start on the x-axis, that's my initial side, and where I end is called my terminal side. This right here is theta. And I can draw myself a little triangle, because I can drop a right triangle, I know about that. This is -2, this is 3, therefore this right here must be a squared plus b squared equals c squared. -2 squared plus b squared is equal to 3 squared. 4 plus b squared equals 9. So b squared equals 5. B equals the square root of 5. I'm going to leave it as that because I want an exact value. So my x in this case is actually -5, right? I went to the negative direction. I'm sorry, radical 5, not -5. So this is negative radical 5 here. So sine is equal to y over r. Cosine of theta is equal to x over r, so it's equal to negative radical 5 over 3. And then they asked me for the cotangent, which if tangent is y over x, then cotangent must be x over y. Since they're reciprocals, x in this case is negative radical 5, and y in this case is -2. My cotangent is -5 over -2. Oh my goodness. Radical 5 over 2. Positive. Negative divided by negative leaves me with the positive. When we're talking about this piece right here, and we're talking about ASTC, the reciprocals are true as well. So in the second quadrant where sine is positive, so is cosecant. In the third quadrant where tangent is positive, so is cotangent. In the fourth quadrant where cosine is positive, so is secant. It's just the reciprocal. So the signs for the reciprocal and the original function are the same. An angle whose terminal side lines up with the x-axis or the y-axis is called a quadrant angle. So remember, the graph is cut into 4 quadrants. An angle that doesn't lie in any quadrant but on a quadrant is called a quadrant angle. So we would look at this first angle here is 0 degrees and 0 theta. This angle right here would be 90 degrees, and the same thing as pi over 2. If we're talking about a unit circle, so let's say this is the value 1 0, this would be the value 0, 1. Over here, 1, 2, 3, 4, 5, 6 would be the value. Okay, at 180 degrees, which is, I'll go 6 over this way, 180 degrees is equal to pi radians, and that value is -1, 0. Down here, we're looking at 270 degrees, which is 3 pi over 2 radians, and the value here is 0, -1. And then one loop all the way around leaves me with 2 pi, which is 360. Remember, 0 and 360 are coterminal angles. So you can see I jumped a little bit. It might be easier if you pause the video and then write this stuff down and catch up. But I did sine of 90, cosine 90, sine of 180, cosine 180, sine of 270, cosine 270, sine of 360, cosine 360. Sine is y over r, cosine is x over r. I'm just writing all these out so that I get used to seeing it. All right, for 90 degrees, I'll put all my y values in green and all my x values in pink, just so I don't confuse myself. So for 90 degrees, the y value is 1 over a radius of 1. We assume we're in a unit circle, so our radius we're always going to assume is 1. So 1, the x value is 0, so cosine of 90 is 0. At 180, so I'm right here, at 180 my y value is 0, so sine of 180 is 0, and my x value is -1, so cosine of 180 is -1. At 270, my y value is -1 and my x value is 0. And at 360, my x value is 0 and my y value is 1. These values are going to be key when we start graphing the functions in 5.4.